So this activity here, guys, I like this little activity. Quiet, please. All right, I like this little activity because it kind of takes everything we're going to be talking about for the next few weeks and puts it all into one assignment, and in a way that I really don't need to teach you. You could probably just figure it all out. So it's kind of neat. So it's a nice way to kind of get your brain jump started on this sort of stuff. So we have an excerpt here from the book of Alice in Wonderland. So I'll read it to you guys and then we'll get started. So it says, Alice found a little bottle, and tied around the neck of the bottle was a paper labeled with the words, "Drink me," beautifully printed in large letters. So Alice ventured to taste it, and finding it very nice, she very soon finished it off. "What a curious feeling," said Alice. "I must be shutting up like a telescope." So you guys know the old school telescopes, like pirates.
Oh yeah, the heart.
Okay, so what she means that she was shrinking is what she means shutting up like a telescope.
Is it really? Can you read it in a British accent?
I'll try. And so it was indeed. She was only 10 inches high. Soon her eye fell on a little glass box that was lying under the table. She opened it and found in it a very small cake on which the words "Eat me" were beautifully marked in courants. I'm assuming courants is some form of cursive writing. She ate a very little bit and very soon finished off the cake. "Curiouser and curiouser," cried Alice. "Now I'm opening out like the largest telescope that ever was. Goodbye, feet." So she's looking down at her feet. She's going up so fast it looks like her feet are like disappearing. Yeah. For when she looked down at her feet, they seemed to be almost out of sight. They were getting so far off. Just at this moment, her head struck against the roof of the hall.
What happened to the British accent?
I'm being a narrator. All right, so here we go. In Lewis Carroll's story, whenever Alice drinks the beverage from the bottle, she gets smaller, and when she eats the cake, she gets bigger. So, where was I? So we're going to start off here. So, suppose that Alice starts off being 4 feet tall. She was a little girl. I want a nice round number, so I chose 4 feet tall. Sounds pretty reasonable. And that for each ounce of cake that she eats, her height will double. Okay? So I want you guys really quick to go ahead and fill in this chart. So she's going to eat an ounce, and every time she eats an ounce, her height doubles. Okay? So how big will she be after 1, then 2, then 3, then 4, then 5? Go ahead. I'll give you a few moments, and I'll call on you. Sometimes people just keep going up by 4, but that's not what happens. Her height is doubling every time. So if you double 4, right, you get 8. And if you double 8, you get 16, etc. So every time she eats an ounce of cake, her height will double from what it was before. Okay, so there it is. Now we're going to graph it. So 0, 4, we're going to estimate. These are points, right? This is my x and this is my y. So I'm going to go over none and up 4. Here's 20. I would estimate 4 being like right about there, right? And then let's do 1, 8. So I'm going to go over to 1, which will be halfway here between the 0 and 2. And I'll go up to 8, which is pretty close to 10, so about in the middle there on the way to 20, and so on. I want you guys to go ahead and plot the rest of these points. Well, I guess I could just do it. I can't really call on you guys to do that. So I'll just go ahead and do it. So 330, that's the next one? Oh, 216. Not quite at 20 yet, but closer, right? 332.
Kind of like in the middle up.
Yep. 464.
Like a little above.
Good.
Or 60.
Right above 60, because that would be 70, right?
Too high?
Yeah.
I agree. Thank you. All right, 5, 128.
Whoa, a little above 120.
So as you guys can see, this is not a straight line, is it? Right? This is a curving line. It goes like this. Well, the type of functions that we're going to be learning about in this chapter, that's what they look like. They look like that. You might be wondering what happens over here on this side of the graph. It does something too. But we'll learn that later. Yeah? Yes. You can go. All right. Let's go ahead and continue here. So why don't you guys try this one? Now suppose she starts to drink the bottle of fluid titled "Drink Me," and that when she does this, her height is reduced by 50%. And you guys, 50% is just a fancy way of saying what? Divided by 2 or half, right? So we're just going to cut it in half. For each ounce of fluid consumed, complete the table chart below. So So now she's 128 feet tall, right? But let's say she drinks 1 ounce. What will she be? Okay, I'm going to let you guys finish this table and graph it. Okay? Go ahead and do that. I'll pause for a little while. Kiara, give me some numbers here. Yes. Hold on, I lost it. There we go. So, go ahead. 64 was here. Now what? Uh-huh. 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 All right, so she got back to her normal height. When you guys were done with this, I'm not going to be real precise with my dots, so don't judge me here. I don't want to take time for that. But your graph should look something like that, right?
Yeah.
Okay. So, the graphs that we're doing in this chapter, those types of functions, they can go one way or the other depending on whether they are an increasing function or a decreasing. And we'll be looking at both of those. All right, so now we have some other interesting questions to kind of consider here, but that's most of the basic idea there. Let's go ahead and look at the next one. Now, I want you guys to ponder number 3 and number 2. I'm sorry, number 3 and 4. So go ahead and ponder number 3 and 4. I'll give you a few moments. Fill in what you believe the answer. Hannah, did you get number 3?
I was guessing if it was just a half.
A half of a thing? I don't think so. Here, I guess I need to be clear on my question because there's you could interpret that differently, right? So assuming that she started at 128, right?
Oh.
So if she started at 128, we found that by the time we got down to here, she was 4. So if she got to 5, now her height is 4. So I'm asking you, how many more would she have to do to get to 1? Okay. You have an answer?
Yeah.
What'd you put?
Well, I put 6 and a half, but technically 1 and a half because you said how many more. I put.
Oh yeah. I see what you're saying. Let's test your theory. So if she had another sip, where would she be at?
2.
And another sip? Now she's at 1. So 7. She would need 7 sips to get to 1. Now,
Wait. 6 would be 2, right?
6 was 2 and 7 is 1, yeah. So there's our answer number 3.
Come here, Mr. Gaines.
Now, I'm going to give you guys a little bit longer to think about this one. Yes, I will. At 7 drinks, we're at 1. So if I go to 8 drinks, what will her height be?
A half.
You divide 1 in half. What would you get? 0.5. What if she had 9? You can take half of that. Divide that by 2. 0.25. Divide that by 2. Divide that by 2. You could do that all day. You'll never get to 0. It gets smaller and smaller and smaller, but it will never get to 0. So the answer is that's impossible.
No solution.
She would never just disappear. She might be like Ant-Man and get lost in the quantum realm,
Oh, we could just
but she'll always exist.
Oh, heck yeah. That's my movie.
I like the way you put it there.
All right. So,
That's me. What if we were sitting here for like ever just doing that?
well, that was the idea.
Wait.
I mean, that shouldn't be possible because she'll run into that bottle at 20 years.
Danielle would get mad at
She
me.
couldn't even reach the ball.
All right.
The bottle was crushed after like 7 sips.
So, read this, guys, number 5. Read number 5. And then I want you guys to see if you can find the first blank, and I'll tell you if you're right. Give them a minute.
Well, can you come look at it?
Yeah.
Please never call me.
Okay.
So,
it's
how
the
to call me?
All right. I just gave you. All right. So, where was I? Natalie. What goes here? Okay.
12.
It's 12. Now let's see why it's 12. Her height is increasing by half.
Can I explain it?
No. Thank you, though, but I want to say it's because it's confusing to you. Ready? So quiet down, please. All right. So it says her height is increasing by 50%. So what's 50% of 8?
4.
4. So if I add 4 feet to her height,
That gives you 12.
that would be 12.
And then,
So you take half of the number and add that much on.
yeah, I got
So let's do another one. If you take half of 12 and add it, what would you get?
18.
Okay.
27, right?
Yeah,
And
27.
then I got stuck there because I was like, what?
Yeah,
Well, now we got decimals. So, just what's half of 27?
13.5.
Okay, so half of 27, if you took 27, you divide it by 2, John, you would get 13.5. You could use a calculator if you want to. So half of 27 is 13.5. So if I add 13.5 to that,
That's 40.5.
is it 40.5?
Yes, it's 40.5.
Sorry, Adrian. I didn't. All right.
Oh.
And then so on. Did somebody get, what would you get for the last one?
60.75.
Yeah. I got pretty close to that.
Okay,
Wait, are you doing this in your head?
let's graph it.
I did-
And by the way, I had a mistake. I said suppose Alice is 4 feet tall. What's her starting height?
8.
It's 8. So change that to an 8 for me, guys. I had a typo there. All right. So let's graph it really quick, and then we're gonna be done with this little activity.
This was easy.
Good. So what I like about this activity, you guys, is it kind of captures almost the entire chapter in one problem. The last question says compare this graph to the one we did in number 1. They're both going the same way, right?
Yeah.
But what's up with this one if you compare this to number 1?
It's like, it had like is it like a vertical shrink?
Yeah, good. It's a vertical compression or a vertical shrink. Yeah, good. It's flatter, right? So, what I like about this little worksheet here is that it helps you understand what exponential functions are. They are things that go up by multiplication. We saw that earlier when it was times 2, times 2, times 2, right? It also helps you understand what their graphs look like. And it also low-key introduces that idea of approaching a number but never getting there, like the 0 thing. Remember that? That's important. I think we talked about this with rational expressions too. What did we call that thing that your graph is trying to approach but can never get to? Well, that's the number, but what's that line called that it's trying to get to but it can't? It's a hard word. It almost sounds like a dirty word. Asymptote. Okay. So these have asymptotes too. Remember how I told you like we didn't know what the rest of our graph looked like. On number 1 it looked like this, and I said, well, I'll show you what the rest of it looks like. Well, on the other side, it just gets flatter and flatter and flatter. It's approaching a number. It'll never get to 0, but it tries to get there. It keeps trying. Just like when Alice kept drinking, she could never quite disappear, but she does get smaller and smaller and smaller. Okay. So I like this little worksheet. It's a nice way to enter. But we're going to go ahead and jump into our actual assignment here now. So let me pass out the... So we're going to... You'll probably need some paper. You might be able to just write on the back of that half sheet I gave you if you want. All right, so today we're going to learn what an exponential function is and how to get an equation from the data. So for instance, we talked about that Alice in Wonderland problem today, right? By the end of the day, you guys should be able to look at that. Okay, guys, quiet, please. You should be able to look at that table of data, and you should be able to write me an equation for that data, okay? That represents an exponential function. That's the goal. All right. I don't know. Kind of just disappeared on me.
It's still recording. It's telling you that we still haven't worked together.
It's shy.
Un momento. There we go. All right.
We're still talking about cake.
So
No.
I'm going to tie in our little discussion here to this. So let's see. What is an exponential function? This is your definition. An exponential... Ooh, squeaky.
Whoa.
An exponential function is a function that increases or decreases by repeatedly multiplying the same number. That number that you multiply by over and over and over is what we call a growth factor. Okay? So there's some words there you want to know. So like on the first thing, when she ate the cake, what did we multiply by over
2.
and over? Yeah. So in this case, my growth factor was 2. Okay, so that's my growth factor. Now, the next two are not quite as straightforward, okay? So the next two aren't quite as obvious. We are multiplying by something, but if I asked you guys what we were doing here, I know what you guys would say. You guys would say we are dividing.
You're
There you go. So you could think of it as dividing, but you can also think of it as multiplication. I want you guys to think of it as multiplication. Dividing by 2 is the same thing as multiplying by 0.5 or a half. Okay? So now, in this case, we're multiplying by a half over and over and over. And so in this case, that would be my growth factor. Now, when the numbers are getting smaller, you could call that a decay factor if you want to. In the world of exponential functions, when it's getting bigger, we call it growth. When it's shrinking, we call it decay. But I wouldn't mark you down if you said the growth factor is 0.5, but you could also call it a decay factor. All right, now this next one is tricky because I was trying to help Daniela with this one, how to get this next number, and she was having a little bit of a hard time with it. And the reason why is because she was thinking the way I want her to think now, but she wasn't thinking the way I wanted her to think then. She was thinking, well, you're not multiplying by anything. And she's right. What did we do? We took half of it, and then we added it, right? But let me show you guys something interesting. Do you guys have your calculators?
Yeah.
What is 6 divided by 4?
2. No.
1.5. What is 9 divided by 6? So that's kind of weird, and I'll explain that to you guys in just a second. But what's my growth factor there? It's 1.5. Is this growth or decay? It's growth. It's getting bigger and bigger. Now, so this one's weird, but let's think about it. We said that she was adding half her height in, right?
Yeah.
So the 1 represents what her original height was, plus an additional half makes 1.5. Does that make sense? It is. It is times. And I also want you guys to notice this as well. How do you find your growth factor? Well, I wonder if we'll get there. We'll get there. For now, that's good enough. So these are exponential functions because they're going up or they're decreasing by multiplying the same number over and over and over. And that's what we call a growth factor. And that's what makes an exponential function an exponential function. Okay? So, exponential functions is when you repeatedly multiply the growth factor. All right, now, let me progress here a little bit. Now, how many times did I have to multiply by 2 to get to 128? 5 times. Now, don't you guys agree then I could just take her height and I could multiply that 4 by 2 5 times, right? 4 times 2 would be 8, times 2 would be 16, times 2 again would be 32, and keep going until you got 5 of them, right? And then you would have 128. But what you said is important there. Instead of writing out 5 2's being multiplied, what's a shorter way to write that, you guys? 2 to the 5th power. This is why they're called exponential functions. When you multiply by a number over and over and over, you might as well just put that number with a power of how many times you want to multiply it. So for instance, what's her starting height for this one? 128. What did we multiply by over and over and over for this one? 0.5. And you could do that as many times as you want to. Like if I wanted to jump down to how tall she would be after 5 drinks, 1, 2, 3, 4, 5, I would just plug in 5 here. That's how many times I'd be multiplying this to her original height, and it would give you the same answer. What would I write for this one?
1.5.
Good. That's the growth factor. What would go here in the front of it?
4.
4. The starting height is 4. We're multiplying her height by 1.5 as many times as you want to. And that's why these are called exponential functions. So when you have a function where you're multiplying where you're increasing or decreasing by repeatedly multiplying the same number called the growth factor, you get an exponential function where the variable is your exponent. Okay? So, hi.
I brought friends.
You don't have any of those. Oh, Tim.
Yeah, I know.
So guys, find this slide that I printed for you. We're going to label some things. So here's what this number in the front is. It always represents your starting amount. So let's label that. That's our starting amount. That's our starting amount. What the B represents. What am I going to call that? Great job. That's our growth factor. That's the number that you're multiplying by over and over and over. Okay? Now what the X represents is, that represents the number of times you're multiplying the growth factor. But shorthand, I'm just going to say it's the input. In other words, when you're thinking of this as a function, that's the number where you're going to plug a number in so you can find y, basically. Okay? So, y represents the final amount. So like the answer you get, that tells you like Alice's final height. So this is the final amount. And mathematically, we would call it the output. So those are the parts of that function. So hopefully, at this point, you guys could tell me a few things about exponential functions. Okay? Hopefully, at this point, you guys could say, well, an exponential function is one that goes up by multiplication. That would make me happy. Another thing that I hope you guys will be able to do is you'd be able to say, an exponential function is one that looks like this, where you have an x in the power spot. That's an exponential function. Another thing I hope you guys will be able to tell me is that I know the graphs. They look like this or they look like this. One of those two, because that was from our Alice in Wonderland worksheet. Yes, they do. All right, so let's continue on with our journey. So now I'm going to actually do some problems that will look a lot like what you guys are going to do in your homework tonight. So this is what you'll be expected to do. All right, so go ahead and find that slide.
What the?
Every time I change a slide, that's... You know, like when you guys... Do you ever do those read-alongs? Probably not. You kids are in the electronic age, but... did you guys ever read-alongs when you were kids where, like, you read along with the book and then when it's time to turn the page, it goes... You're supposed to turn the page. So every time I change slides, Henry's... What the? So that means we've changed slides. And you hear Henry say, what the? It means change slides. All right. I'm going to puberty.
Boy, going to puberty again?
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 It's my first time. I'm just kidding. Okay. All right. The table at the right is a collection of data for an exponential function. All right, ready? What's the starting amount? Okay, it's 5. How do you know it's the starting amount? When x equals 0, that would be your starting amount. So you look for where x equals 0. That tells you what your starting amount is, okay? So he's right. 5 is correct. Okay? Now the next one's a little bit tricky. You guys ready? Growth factor. That means what am I multiplying by every time to get from here to here? Now, how do we figure that out? I'll show you. You take your second term, or your second, let's be more specific. Let's say you take your second y value and you divide it by your first y value. That will tell you what you had to multiply to get there. So for instance, on your calculators, guys, do 6 divided by 5.
1.2.
There you go. So my growth factor is 1.2. What that means is I am multiplying by 1.2 every time. So check this out. And you could use your calculators to verify this. What's 5 times 1.2? It should be 6. And then you could do 6 times 1.2. You should get 7.2. And so on.
6 divided by 5 is...
So then, that would mean that the last one's 10.36.
Actually, no, because look what I did. I skipped a whole bunch. And I'll talk about how to get this one in a minute. But the next one is not going to be just 1 more times 2, or 1.2, because we were going up by 1 every time, but now we're skipping all the way up to 10. Now, you could do it by hand, but I'm going to show you guys a faster way. Yeah. So, here we go.
What about number 4?
We're getting there. Here we go.
Have we done number 3?
Not yet. So what was my starting amount? 5. What was my growth factor?
0, 1.
If you know those two things, then you have enough information to get your formula. Okay, the formula looks like this. You have your starting amount times your growth factor with an x here and a y there, and that's it.
That's number 3.
Yep, that's number 3. That's number 3. Write an equation to model this function. You put your starting amount in the front, growth factor in parentheses with an x on the power spot. Because this is what I'm multiplying by, and this is how many times I'm multiplying it. Now, I want to use my equation to complete the table. Now, you could just do it by hand by multiplying by 1.2 over and over again, but we can make it easier on ourselves, right? How many times would I have to multiply 1.2? 10 times, right? So starting from 5, we would multiply 1.2 10 times. In other words, it would be 1.2 to the 10th power. So all we have to do to complete our table then is do this, but where the x is at, we're going to plug this number in. Now at this point, you guys are going to need a little help on your calculators, okay? So I'm going to walk you guys through this.
Are you sure?
Well, some of you may not, but some of us do. So here's how you guys are going to do this on your calculator. And I would even encourage you guys to write this down. Push 5. That's for this number. And then I want you guys to push times. So you should see like a little star now. And then 1.2. And now this is where things get weird. How do we do the 10th power? You guys are going to find the little button that looks like this. It's in the middle of your calculator on the left side. You guys see it? It's called a caret. All right, so push that. That's your power button. And then you're going to type 10. What? And then equals, of course. So what's the answer?
It's like 30.9.
30.95.
Okay, there it is. 30.95. I'm going to round to the thousandths place, but there you go. All right, so that's how you do the calculator work there. So let's review a few things before I set you guys loose. Danielle, how do you find the starting amount?
Is the equal to 0 one, right?
It's the y value that's next to the x equals 0. Good. Next one. Javier's not with us. Let's try Heidi. Heidi, how do we find the growth factor? Not sure? This is important, so make sure you guys know this. I want to try Heidi, so listen to this, okay? Nathaniel Robles, how do we find the growth factor?
You divide your second term by your first term.
Yes. Now second term meaning the
Y value.
y values, right? So second y value by the first. So 6 divided by 5, right? Good. And then Adrian, how are we going to complete the table?
Use the formula.
That's right. You're going to plug the number for x into your formula and then use your calculator. Now, by the way, remember how I said to find your growth factor, you do second y value divided by first? You guys could do that with any of them. Like you could do the third one divided by the second. It should still work. Just always divide one y value by the one that comes right before it. That'll always tell you what you had to multiply to get there, right? That makes sense. Okay, so now you guys get to practice some student practice. I think I printed them for you. So they're right there on your sheet, but I'll project them up here for you as well. Go ahead. You guys are fine. No biggie.